Hi, everybody. Thanks again for taking the test last week. All the grades have been posted. Keep in mind the last day to drop and get a W in the course is November 14th. So that is next Thursday. If you are thinking you might drop and you don't drop, then at the end of the semester, I have no choice. I have to issue you a grade, whatever grade that is that you get. A couple things to keep in mind as you're looking at your grades. The grade that shows in Canvas does not have your high and low test averaged. So if your homework grade is above 90, then the grade that's in Canvas is the worst grade that you could possibly have right now. But by averaging your highest and lowest test grade and replacing the lowest test with that average, your grade will be higher than it is in Canvas right now. How much higher depends on the difference between your highest and lowest test grade. This week is going to be a little complicated, okay? These rational expressions that you've been looking at for the last week, you've seen they operate a lot like fractions, and so kind of breaking up the sections a little bit, the first thing that you're going to look at this week is least common denominator. Just like with fractions, when you're adding rational expressions, you got to have a least common denominator. And finding it is going through the same process that you would to find an LCD for fractions. It's just more complicated because everything is polynomials. Once you find the LCD, then rewriting your fractions with the least common denominator and then adding and subtracting, without one. The complex rational expressions I want to kind of take a look at. These are horrible looking. Don't let the way that they look intimidate you, because as you work your way through this, one of the things that you're going to see is that, remember, every fraction is a division problem. So these complex rational expressions, like the one on the right here, it's just a big division problem. And so the easiest way to deal with it is to rewrite it as a division problem. So if I made this x minus 2 over x plus 1 divided by x squared minus 9 over x plus 3, then I flip and multiply and factor and simplify, and I'm done. And so these can look horrible, and they turn out to not be too bad. And once again, just like we've been seeing, these PDFs are here, and some of you are opening them and looking at them and finding that they help, and some of you are not even opening them, not even looking at them. Here's an example that I was just talking about where we could rewrite as a division problem and then reconceive it as a multiplication problem, and then flip, multiply, factor, and simplify, and we are done. Okay, so there's a lot of examples in here to kind of help you work your way through it and to see how to do how to simplify these complex rational expressions. Okay, as we move into next week, you will then solve rational equations, and then move into systems of linear equations, all of which is important as we move forward. Our last test is December 7th, and I'll give you more information as we get closer to that. All right, email me if you have any questions. Let me know how I can help, and we can always meet online if office hours or the time that I'm in the math lab don't work for you. Thanks a lot.